Now, I present Mikaeil Orfanian with topic Design and Architecture in Everyday Programming.
Hello, everyone. So my name is Mikaeil, and I am a software developer. I usually write code in Python. And this talk is based on various ideas by people like Uncle Bob, Gary Bernhardt, and Brandon Rhodes. Also, I would like to thank Łukasz Żukowski and Ignacy Sokołowski for pointing me in the right direction early on in my career. So after working on dozens of large code bases, I have come to notice that a set of small issues are responsible for most of the negative feelings we as developers have about our applications. We hate it when a small change in one part of the application ends up being a big change. We often choose to tolerate inferior solutions because we fear the unforeseen consequences of touching the code that works, but it's terrible. Our tests, they're hard to write. They're sensitive to change, and they get slower as the code base gets bigger. Our business logic is confusing. We often complain about why certain things can't be done because of how other things are currently implemented. And new people take weeks to find their way around the code base. Well, in this talk, I would like to show you how you can avoid such issues by following a few guidelines. And those are: keep your I/O-related code separate from non-I/O related code, keep your business logic separate from non-business logic, and focus on writing and testing your business logic first. But before we talk about these guidelines, let's take a look at an example application and see how implementing it the usual way leads to the mess we always want to avoid. So this is a picture of my mailbox. I'm subscribed to the Python mailing list, so I receive emails like this, usually daily, multiple times a day. There are a couple of things my mailbox cannot do for me, which I really would like to have. As you can see here, an email is either read totally or not read. The problem is that each email contains multiple topics, and as you can see, they're numbered here 1, 2, 3 on the right side of the picture. And so these are like messages related to a topic. And sometimes actually the topics go across different emails. So sometimes I do actually have to go back a few days to a few days ago, all their emails, to see what's been discussed already. So I've designed a new user interface that I think will solve the problems that you saw with the mailbox. The central idea here is that of topics and messages. So instead of emails, we now see a list of topics on the left side, and a topic can consist of multiple messages. Topics receive updates when a new message related to that topic appears in a new email. So a topic could be read today, but not read tomorrow because it receives a new message. And now let's take a look at some code I've written for the backend of this application. By the way, this is a pseudocode or Pythonic pseudocode, so it doesn't really work if you run it. And as you can see, I'm using some Flask-like framework to handle HTTP requests, and this function returns the view that we saw in the picture previously. So let's see what happens here. We update topics, so that involves fetching emails, building messages and topics. Then we fetch all the updated topics from the database, we pass them to the template, render the template, and return that. And the most interesting function here for our purposes is update topics. So that function calls two other functions. Get messages is responsible for fetching and parsing emails and building messages, message objects. Save messages connects a message to a topic and then saves that message to the database. So in this picture, I've marked the segments of these functions that do I/O with arrows, and the parts that do business logic with a picture of the brain. And I'm going to consider some questions now. First of all, where is our business logic? And as you can see, it's spread among three functions. In those same functions, we're fetching emails, like making HTTP calls, and also making calls to the database for saving messages. But the main question is, so what? What's the problem? So what are the consequences of mixing I/O and logic in the same function? Well, here we've created a dependency between the logic and the database, or calling some resource over the internet. And for example, would changes in get messages affect the code in save messages? Yes. And how about testing? How would you test these functions? Will we need to mock anything, the database or the HTTP calls? Will we be able to test the isolated pieces of business logic without having to use these mocks? Let's look at one specific example. So we want to test the parsing of messages from emails. Basically, we are targeting the previous function, get messages. So some of the test cases we would like to consider could be multiple topics within an email, multiple topics, each one with one message, multiple topics, each one with more than one message, just one topic with one message or multiple ones, messages with the same topic from multiple emails, and on and on. The point here is that there are many potential test cases because we're dealing with logic. So, how do we write all these tests? Are we going to mock all the HTTP calls in every test case? Usually that's what happens. And note here that I'm only talking about a function that was 5 lines of code, and there was another function there, save messages, that was calling the database. So you can imagine that the same kind of explosion in test cases could happen there. And in the code bases I've worked with, usually we don't mock the whole ORM. So if you work with Django, usually we just use the Django test classes. So you probably have seen, I don't know, maybe these test modules where every test function has multiple decorators. These decorators are usually duplicated in multiple places. They're basically the same decorator used over and over again. So in summary, what we've done is we have confusing business logic, we have hard to write tests, we have boring test setup and teardown code, we have slow tests, and we have a snowballing of changes. So this hell that I've created is due to several design choices. The biggest failure, in my opinion, is that I've mixed business logic with non-business logic code. So the question now is, what is this business logic that I always talk about? In this example, converting emails to messages and creating topics on top of them is a good candidate. There is no I/O involved in this process. This logic is quite unique. As much as we would like, there's actually no library or framework that does what we want. In fact, as developers, we are usually hired to write the library code for business logic. This is in opposition to I/O and non-business logic code. There are usually libraries and frameworks that take care of these things. And we're almost never hired to create ORMs or web frameworks. Now, some people might say, hold on, just a second. I/O is an integral part of our business logic because we have a microservice architecture. And when a request arrives, a bunch of services need to talk to each other. And for us, that is business logic. And I was actually part of a project, and we discussed issues like this. Another thing was, well, let me go back to that one and address that one first. In the case of microservices, I would say you can think of each service as a module or a package that you can import in your code. So if you do that, then basically what you've done is consolidated all of them into one application or one monolithic application. And the I/O goes away, right? So how is it that the business logic disappears when you change the architecture? So you can also, I worked in another project where we were heavily relying on transactional systems. And so we also had questions like, well, if I/O fails and I'm in the middle of a transaction, I want to actually roll back all the things I've done up to that point. Well, isn't that logic? Isn't that handling with I/O part of the business logic? Well, the same thing about microservices is true for transactional systems. You can treat I/O failure the same way that you treat other failures, like data validation. From the business logic point of view, another system's failure is still a failure. An I/O-related exception is an exception after all. So let's now go back to our guidelines. And this time, we know what those words mean. So I've made a second version of the application according to these guidelines. Okay, so you should see a difference here. Notice the difference. Based on those markings, you can see that this function is calling other functions that do either I/O or business logic. So let's take a look at these functions. I/O is limited to get new emails and save messages. Business logic is isolated to functions like get messages from emails and get messages. Note here that we can test these business logic only functions without having to mark anything. We could write hundreds of tests that run in milliseconds. Writing such code is not intuitive at first. Most of us are not used to it. When you search online, you don't see code like this. What you see is a mix, if you do a tutorial on Django, you see a mix of everything in each function. So that's why in addition to these guidelines, I found, based on experience, that following some tips can be extremely helpful. So the first one is focus on business logic first. Usually when we start a new project, we spend time deciding which framework to use. Then we pick the ORM and then the libraries. Instead, try to delay all such decisions for as long as you can. Imagine that there will be no web application. There is no need for a database, no user interfaces, and that everything you need is on the same machine, the same process or thread. Everything you need is present as native Python objects. The motivation here is to not have our business logic depend on non-business logic code. And this is the easiest way I've found to achieve this. This way, we avoid having to make decisions that create dependencies between I/O, business logic, and framework-specific code. And you avoid those decisions because those things don't exist yet. So if you want to separate functions that do I/O from functions that do logic, then how do we mix these two types of functions? Who's orchestrating the interactions between them? Our goal here is to minimize the number of functions that include both I/O and business logic. It would be great if we had only one such function per feature. And here the feature is rendering the topics to the user. Usually the highest level functions are the best place for mixing I/O with business logic. The side effect of this is that our functional integration test can target only one function. The number of test cases will be small because we've already unit tested the logic and the I/O code. This means that our slowest tests, which are integration or functional, will be very, very simple, and there will be just a few of them. The next tip is to take the idea of microservices to an extreme. Treat each function as if it's going to be a service on its own. Thinking about functions this way minimizes dependencies among them. So if you imagine a change in function that affects other functions, and if each function is a microservice, then a change in one microservice would have impact on dozens of other endpoints or APIs. And this is crazy if you've worked with such systems. And it forces you hard to want to avoid this. Another benefit here is, again, testing. Do we usually write unit tests that cover multiple microservices? No. We call such tests end-to-end, functional, or integration tests. Definitely not unit tests. This means that if we treat each function as a microservice, then the tests for that function would only test that single function. In other words, you end up unit testing just a single function. So that brings me to the conclusion or the end of this talk. So here's a summary. Keep your I/O framework and logic code separate from each other. Focus on writing and testing the business logic first. Try to delay decisions about things like frameworks and databases. To minimize dependencies, bring I/O to the highest level functions and aim for one such function per endpoint or feature. Treat each function as though it's on a different machine. So if some of these things are not clear to you, I'm giving another talk called Hands-on TDD of a test-driven development of a clean architecture also today at 3:30. And you're welcome to come to that talk to learn about how actually this is done. We will be coding the same application from scratch. And this is my email. If you would like to contact me and talk about these things, mokt@outlook.com. And that's the other one is my blog. I'm not very active, so I think this talk will be the only thing I will put there in the next few months. And I haven't done it yet. So, yes. So now I'm open. I had 45 minutes. I've used only 20 minutes of that. So I'm open, I guess, for questions or comments, or maybe someone would like to challenge what I said. That would be welcome. I would like to learn more. So if you think I'm bullshitting, let me know. Yes, please.
what are the tools available, for example, for Python project that will help you to enforce those guidelines you just listed?
I usually don't use any tools. Maybe the only tool I use is the test runner, and these days I use PyTest. And usually I write the tests first, and like I said, I try to not think about the database and the architecture, is it microservice or not, what other services am I talking to. I just assume that everything is right in the program that I'm writing, that every object is a native Python object, a dictionary or a simple class. And I would say maybe the best tool would be a code review, but by other people who also agree on these guidelines, let's say.
And a follow-up question, do you know a good resources people could check, a book or a blog or a web page where those things would be explained a little bit in more details?
Yes, so Uncle Bob has an entire book called Clean Architecture. He also has a blog post on this, so if you just Google that, you will see probably his blog post, which is shorter than his book. But for me, it was kind of too complicated, so I had to reread it a few times, and I still couldn't get it. And even though I watched some of the videos he has on his website related to this, I still could not understand, because what I've shown here is actually a mixture of 3 or 4 different things. So there's also Gary Bernhardt, which has a talk called Boundaries. He also gave 3 other talks in different PyCons. So if you go to this website called PyVideo and try to search for his name, you will see all those videos. And basically he goes, it's much simpler than Clean Architecture, but it's pretty similar. And he goes through what I just talked about. There's also Brandon Rhodes, and he has a talk also at PyCon, the Clean Architecture in Python, which is also somewhat similar to what I just said. I think those 3 would be pretty helpful. I mean, for me, that was enough. Of course, having experience in a team, actually being able to maybe convince your teammates to also value such guidelines and want to follow them. That for me, that part was much more challenging than me myself understanding and agreeing. There's also other things called the hexagonal architecture, which is basically similar to this. And yeah, I think if you would like I said, I will put this on my website, and you can come back to it and Google those resources.
Thank you.
You're welcome. So there was, yes.
Right, so when would you not use clean architecture? Like, are there projects that you would look at them and see like, okay, so this time it's not worth it?
Yes, if you see that it overcomplicates things. So if you start writing test setup or fixtures, like you've written 5 lines of code and you have 10 fixtures, maybe that's a red flag. At this point for me, I'm so used to it that it helps me think. So it's not just that I want to have good code. It's just it helps me actually do the things I want to do. I have a pretty bad memory, so I would like to have something that when I come back to it, I understand why I made some decisions. And so, like I said, TDD mixed with this clean architecture could be useful. Actually, I don't do clean architecture because if you go to that book or article, you will see that Uncle Bob has layers and layers. He has names for these layers, and there's like objects that bridge these layers, and there's like rules between how the flow of the application can go from one layer to another. Most of the time I don't do that unless I'm dealing with a huge system where I'm using like, a hierarchy of objects, and I'm heavily using some OOP code and things like that.
Right, thank you.
So there's, yeah. Okay.
Thanks. I have a question about Django. Did you use this approach in big Django projects?
Yes.
And how did you deal with the fact that Django is very much fixed to the whole structure is fixed to the models? How the model or model instance is used everywhere. So you are, if you are following the Django documentation, you are tied heavily with the models. So how do you deal with it?
Well, unfortunately, most of the tutorials you see, not only in the Python community, but also if you go to like the Ruby community, they're using Ruby on Rails the same way. And those tutorials, I guess the issue with those tutorials is their focus. So their focus is they want to show you how to use a tool, which is like Django or Ruby on Rails. Their focus is not to show you how to build an application that's easy to understand and test, or easy to extend in future. But like you see on this picture, I just try not to think about Django or the ORM or the models. In the big system that I worked with, we had our own objects, like our own things. You could call them models, but they were actually becoming a model at the very latest stage before we saved them to the database. And so we try to not really mix Django. I mean, if you are using Django, you have to go to use that folder structure of Django, so you have your apps, right? And so that's something I guess you can't really change much. But other than that, yeah, each app in Django would be one model, and we would just use it as an ORM. And for example, we used other things like the Django REST framework on top of Django that helped us build APIs. But we also did the same thing. So we tried not to think about the REST part for most of the business logic code. And there was only one place in code that you actually go into Django REST framework, and we quickly come out of that paradigm.
Right, so you in fact do not benefit much from Django, yes?
Yes, we do, because the ORM is pretty good. I've used SQL Alchemy. I don't know. I do write tests for saving things to the database if you have complex queries. And if you use something like Flask plus SQL Alchemy, there's really a lot of pain. I saw another project that was like 2 years old, and people still had issues with like resource management, connections to the database and things like that. And when you go to SQL Alchemy documentation, it's like pretty, I don't know, maybe I'm too simple-minded for stuff like that. But basically, when I write code, I don't want to reinvent the ORM. I don't want to deal with database connections and I don't know, things like that, like things failing and rollbacks not working. But maybe one day I should deal with that. But for now, I'm happy not to deal with that. So, yeah. Django's ORM is pretty awesome.
So the ORM is the only thing that makes Django your choice, basically.
And the Django REST framework for making APIs.
Okay, thanks.
You're welcome.
Hi. Have you already worked with a customer-delivered test for business logic, let's say based on contract?
No.
Okay.
Can you repeat the...
Yeah, so when you have test delivered by customer, to test business logic, and it's tied with contract signed with the company.
No, the closest thing I've done or my team has done is to do BDD, so behavior-driven tests, where we try to make them so simple that the business people could also participate. But as part of the contract, like as a formal document.
Okay, so maybe follow up. Did the business use these tests to, let's say, prove your product works correctly in front of customer?
Yes, at some point we also automated these tests. They would run for like 10 hours, and so we would run them once every few days. And this was an application that it was similar to a backend for a bank. We were actually dealing with real money, and each time there was a bug, we would lose like €500,000 or something. And we had so imagine our product as a backend as a service for different banks. So actually we had more than one customer that relied on our wallets to keep their accounting straight. And yeah.
Thank you.
No problem. There was someone on this side.
Yeah. Well, thanks. I indeed also have read the architecture from Uncle Bob, and yeah, I agree that there's a lot of layers. So for me, it's really nice to see this example, and yeah, I think it's great advice. I will try thinking of how long can I just work purely on business logic and wait with the interesting decision of what framework you're going to use. But yeah, I think it's a really interesting advice that I'll try. So thanks.
Thank you. No more questions? Okay, has anyone else heard of clean architecture in this audience? Yes, anyone using it actively? Any experience? So, trying? Yeah. Well, he lives in the like .NET or Java world. Sometimes he talks about Ruby, but I've never heard him mention Python, or maybe once. But so I don't know. But I think that Gary Bernhardt talks, those are pretty awesome. And because he's a Ruby developer, he actually gave those talks at PyCon. That was the point where I realized that he's trying to basically simplify things and bring them from that heavy, Java world to the simpler world of Python and Ruby. And then there's that Brandon Rhodes talk, which is he's even trying to simplify things more. And my talk is basically a mixture of those. So if you guys have issues with clean architecture, I definitely recommend you to check out those other resources. Okay, thank you for your attention.